My name is Anne Margaret Crowe. I'm one of the technology analysts at Edison Group. And it's my privilege today to be speaking with Philip Johnston, CEO of Trackwise Designs, and Mark Hodgkins, CFO of Trackwise Designs. Now, just occasionally as a technology analyst, you come across something that makes you sit up because it solves a very real problem, in this case, addressing the weight and bulk of wiring harnesses, and it does it in a really elegant way. So if we could begin, Philip, can you tell us about this amazing technology that Trackwise has developed and commercialized?
Thank you for your kind and generous introduction. Yeah, so as you can maybe see on the poster behind us, we're calling this improved harness technology because, as Anne described, we believe or we know that it is an improvement over existing wire harness technology. So the technology that we're using is flexible printed circuits. So this is, well, one thing I should say, is not a new technology. A flexible printed circuit was developed in the middle of the last century, specifically to replace wire harness. And the reason you can get your mobile phone inside your jacket pocket is because all of the wire inside that has been replaced by flexible printed circuits, as Anne says, to save weight and in order to save space. Trackwise's innovation removes any size limit. So typically the supply chain limit up till now has been limited to roughly 2 foot in length. And Trackwise, our manufacturing innovation, as I say, allows it to be made of any length. And that means that rather than the technology being used inside a box or equipment, can be used box to box. So therefore, if you look at an aircraft at fuselage level, at wing level, and as we can save 60, 70% of weight over conventional wire harness, as well as saving space, the weight, energy, carbon saving benefits are clear to see. So that is it, improved harness technology.
Right, thank you. And in September last year, Trackwise announced a manufacture and supply agreement with a UK manufacturer of electric vehicles. And can you tell us why it was that the OEM decided to engage with Trackwise?
So yes, so originally the OEM engaged with Trackwise because of our ability to make these large circuits. So the circuits that we are manufacturing for them and for others can either be used at battery pack level or at battery module level. So modules are typically 1 foot square, that sort of size, rectangular cubes of hundreds of individual cells, and those are connected together, in this case by our flex PCBs, into a module, and then at module level they're connected together in larger scale when they're installed into the vehicle to form battery packs. So the original engagement with the customer was our large manufacturing capability, which allowed us to make pack level harnesses, but then has morphed into the manufacture of module level harnesses. So these are, as I said, hundreds of individual cells. They all have positive and negative terminals, and so the improvement that improved harness technology offers there is the manufacturability. So these are very precisely controlled geometry, precisely repeatable circuits that are very suitable for high volume manufacture of these battery modules.
So, Philip, this morning I saw that you issued an update on the program with the major vehicle OEM. Could you give us a bit more colour on that, please?
Yeah, thank you, Anne. So we signed the contract, the supply agreement with the OEM in September of last year, and we've continued to work on the development of their products. And we are very pleased to announce today that the company, the customer, has awarded us an additional year on that contract. So that takes the headline figure of what was up to 38 million up to 54 million. So that's a big contract. Really underpins the business of the the company for a further year, and we're very pleased with the endorsement of the OEM to put their faith in us.
Thank you. And is there potential for working with other manufacturers in the same sector?
Yes, so we have worked with another large UK EV OEM in the past, and have done some more work for them this year. And our ongoing discussions with battery module and battery pack users for both electric vehicles and also for electric aviation. Battery pack shows us that there's really quite a widespread adoption of flex PCBs to either connect, as I say, cells into modules or modules into pack, or both. So yes, we're quite confident that flex PCBs seem to be introduced as a fairly widely adopted use for this purpose.
Right, thank you. And clearly, the electric vehicle market's very high profile at the moment. It's not the only one you're working in. In May 2021, you announced a supply agreement with Cath Print. Can you provide a bit more colour on that and the work that you're doing in the medical sector?
Yeah, thank you, Anne. So a few years ago, we manufactured a 25-metre long circuit, which was for an aerospace application. We've actually just produced a 72-metre long one, but this 25-metre long, which was the largest we'd made at that point in time, got on the front cover of Electronics Weekly, which, as Anne will know, is quite a widely read technology magazine and widely read around the world. So we got onto the cover of that, and that was actually seen by a number of catheter manufacturers. So really, the genesis of it came from that Electronics Weekly cover. Now, unlike electric vehicle battery modules, our flex or printed circuits are going along. They're sort of long, sort of 2 meters, 2.5 meters in length, and replacing tiny micro wires. So if the equipment manufacturer or the surgeon has got a little imaging device or a little tool which they want to manipulate or see inside a patient's body, these need to be connected by the smallest tube, obviously, as possible. And if they're made with the existing technology, which is tiny little micro wires, then these are very tricky to assemble and to test. So our long, thin flex PCBs are replacing these tiny micro wires, and the improvement in this case, for improved harness technology, is the manufacturability of these parts for the OEM. So we have been working with a number of manufacturers, but Cath Print were or are basing their own technology development or their own product development on the very unique capabilities that Trackwise is offering. And for this reason, we signed, as and you've said, a supply agreement earlier this year, and that encompasses the ongoing development that we're going at the moment, but also into 5 years of production. And as I'm sure your readers and listeners will be aware, that the catheter market is a very large one. All of the providers we're talking to are in the hundreds of thousands a year when these go into production, or even larger numbers. So still fairly early days with Cath Print, but they're very nice people, very exciting technology with an interesting application for a large market.
Thank you. And again, that's still not the only sector you're working in. What should investors expect to see with regards to programs in the aerospace sector?
So aerospace is clearly a long burn. So it takes a long time to get new technology implemented, and the pandemic has clearly hit the aviation industry, and therefore its supply chain hard. However, we have some ongoing programs with existing developers. I think the GKN agreement, which is underway, is a matter of public record, and that still represents our best opportunity for product being sold into mainstream aviation programs. However, the innovation, as I said from the outset, the weight and space saving is particular weight and carbon saving ones. So for more electric and all electric aviation, which are been well written about, that the weight saving is a very powerful opportunity. So we've got some interesting development with some well-funded and ambitious new product developers. So I would encourage your listeners to watch this space. But the advantage of the electric vehicles is that this is revenue now, whilst the medical and the aerospace developments go through the regulatory hurdles and into production. But we're confident that they are coming and will come.
So, Mark, I noticed in the announcement that went out this morning that the ramp up in volumes for the major EV OEM was going to be delayed now. So can you talk a bit about the implications of that on FY21 performance, please?
Yes, of course. So we're trying to work closely with our customer and the needs and demands they've got. And they've asked us to delay full production of the parts from the last quarter of this year to the first quarter of next year. And this will have an impact on 2021 revenues, as obviously that's quite a chunk of revenue to lose. So we anticipate quite a big reduction in revenues for 2021, perhaps down to about £9 million, and a consequent reduction in profitability as well, which will be, there'll be quite a significant loss compared to the year we've just reported, maybe as much as £500,000. But we haven't lost any work. In actual fact, over the whole piece, the amount of work that we're now going to deliver has increased by about £17 million. And so we think overall the benefits to the company is quite large, and this is just represents a timing difference.
And finally, Mark, can you tell us about the progress you're making regarding your new site in Stonehouse, Gloucestershire, and the rationale for this investment?
So when we bought Stevenage Circuits last April, we did that so that we could free up capacity here in Tewkesbury to enable us to deal with a large expected order from an EV manufacturer. That order came, and it turned out to be a much larger order than we thought, and we realised we needed to have additional capacity. That led us to identify a property in Stonehouse, which is not so far from our site in Tewkesbury. We bought that site in March of this year for just under £3 million. And we're busily converting that now, just making it ready for an instalment of quite a lot of equipment, for which we raised the money from the market in December last year. So we are now busily specifying and ordering a range of equipment that will allow us to make the EV parts that we've committed to make in a much more autonomous way, a roll-to-roll version, and we hope to have that installed by the end of the year.
Thank you very much. So thank you very much, both of you, for your time, and look forward to speaking to you again soon and hearing an update on the status of the various programmes and indeed on the installation at Stonehouse. Thank you.
Thank you.
Thank you.